Up to this point, you've learned how to solve one-step equations and two-step equations, where you were told to undo the added and subtracted term first. And in this lesson, you'll learn how to solve multi-step equations, meaning you have many steps to perform before you end up with your final solution. And these are examples of what each one of those will look like. One example of a multi-step equation will involve combining like terms. So if you look at example A here, you can see that you have a 2c term and a c term. And so if there are like terms on one side of the equation, you are to combine them first, and then it will become a problem that you recognize. So for letter A, you see that you have a 2c plus c. So go ahead and combine those like terms first, giving you 3c when you add them together. Rewrite the rest of your equation, and then you can see it becomes a two-step equation. So go ahead and undo that added subtracted term first. So that means that adding of 12, you need to take away 12 from both sides, giving you a 66 on the right and a 3c on the left. And then when you divide to undo that multiplication, you're going to end up with c equals 22. Alright, next problem again is a multi-step problem. You see you have like terms on the same side of the equation, so you need to combine your like terms of 4b and 2b. And when you add the coefficients together, you end up with 6b plus 16 equals 46, and then finishing that up, you end up with that equivalent equation, and then go ahead and divide by 6 to undo that, and you're left with b equals 5. Alright, so really not too much new here, you're just putting some concepts together. You go ahead and do the guided practice at the bottom, pause the video now, and come back when you're done. And here's what those answers should look like. This might have become a problem for some of you right here where you had that negative 1x. Just undo that negative 1 multiplication. You do not want a negative sign left in front of your variable that is not isolated. So just divide by a negative 1 if you ever have to. Here's another type of multi-step problem that you will encounter, and that is when you have an equation with grouping symbols involved. So looking at letter A, you have parentheses there, so the only difference there is you're going to have to distribute first and then solve it. So let's look at letter A. I need to distribute that negative 2 to everything inside the parentheses, giving me a negative 2b plus 8 equaling 12. And now again, it's a two-step problem. Subtract the 8 from both sides. That's a 4 on this side and a negative 2b over here. And in order to isolate that b, we need to undo that multiplication. So I'm going to divide by a negative 2, leaving me with b equals negative 2. Letter B will involve all of it together because I have a distributive property, and then once I distribute, I'm going to have like terms. So always start off with the grouping symbols to get rid of them. M is still there, and then when I multiply 5 times m, you get 5m, and then 5 times that 1 will give you that 5 right there, and that equals 7. Looking at this, you have like terms. You have m plus 5m. That will become 6m minus 5 equals 7. A two-step equation now. So you're going to add 5 to both sides, getting you a 12, and finally divide by 6. So m equals 2 is your final solution. You try guided practice here, A and B. Pause the video. And here are those answers. And please make sure you're showing all your work. Every step needs to be seen. You're training your brain to provide a structure for how to solve these equations. And as always, that's going to get harder from here on out. So it's really important that you follow the steps properly. Okay, we're going to look at two special cases. Sometimes we'll have an equation with fractions in it, and you need to not panic. You have two options for solving them. The first method is just by adding your fractions where you would get a common denominator. The second is an extremely handy method called clearing the fractions. I will show you both ways. You just need to be able to pick one preferred method of yours and be able to actually solve them. So I will rewrite this problem down, and what I'm going to do is solve this by adding my fractions together. And hopefully you remember that to add fractions you need a common denominator. So my common denominator between 3 and 2 means what multiple of 3 and 2 is common to both of them. And so that answer would be 6. And so I'm going to need to multiply this fraction by 2 in the denominator and also in the numerator so I don't change the problem. And that's a times sign. I should switch that. We don't want an X. So I'll use dots instead. Okay. And the reason we multiply the numerator and denominator by the 2 is because when you divide this number, it's really just the number 1. And you have learned that when you multiply 1 by something, you're not really changing it. So what we're in fact doing is just making this look different, but it is the same equivalent equation. And you need to only do it to this side because they are still equivalent. So when you multiply those through, this fraction becomes 4x over 6. And this fraction becomes 3x over 6, and that equals 7. And then when you add, because now we can add, we have common denominators, you add your numerators and rewrite the denominator. So you end up with 7x over 6 equals 7. And now this really can be solved in one step. So if we haven't gone over that already, let's do it now. I have a fraction being multiplied by that variable and I want it to go away. I need to undo this fraction. And so if I wanted to undo this division of 6, you know that you would need to multiply by 6, and then these two numbers would cancel. And then right after you were done with that, you would undo the 7 times x, and that would mean that you need to divide by 7. And so if you notice this fraction that I wrote all at once, it's just the flip of this fraction, and that's called the reciprocal. And so when you have a fraction times a variable, you can do what's called multiply by the reciprocal. And that just means flip your fractions and multiply by it, because you know that 6 times 7 is 42, and down here is 42, and they've just canceled each other out. But now the golden rule of algebra says if I do it to one side of the equation, I have to multiply by that same fraction on the other side. And so here, when you multiply through, you would end up with 42 over 7, and then that divides to 6. And so in the end, you end up with x equals 6. Alright, well if you don't like fractions, then clearing the fractions might be the method for you. So let's start doing this. I'm going to rewrite what we originally had. And you still need to understand the idea of a common denominator or a common multiple. So looking at the 3 and 2, that process is still the same. And you would say, what is a common multiple of those? And you know that it was 6. And so instead of making your fractions equivalent to 6, you're going to actually multiply that entire thing by 6 on the left side and the right side. So because 6 is my common multiple, I will multiply everything by 6. And this will clear the fractions. Watch what I mean. Looking at the first fraction, you have 12 divided by 3. Well, that's just 4. And then your x is still there. So I'll say that again. You had 6 times 2 was 12, and then you divide it by 3, and that's 4. And notice you have no fraction anymore. Let's do the same with the second. You have 6 times x divided by 2. Well, the 6 and the 2 divide to become 3, and you rewrite your x down. And then on your right side, you have 7 times 6, which is 42. So you have just cleared the fractions, and now it becomes a simpler problem to do. So 4x plus 3x, I'm combining like terms now on the left side, is 7x equals 42, and then divide by 7, and you're left with x is 6. Again, the same answer as you got with method 1. So your job is to decide which method is more comfortable for you, but I will say when you move on in math class that method 2 will become extremely handy in the future. But as long as you pick a method that works and get correct answers, we're okay. Try guided practice A and B. Maybe try it both ways, or try the method that you don't like. And sometimes when you practice, you end up liking it a lot. Pause the video now. Alright, and here are those answers. I showed both methods, but once again you only need to use one. You can see that method 2 might be a lot shorter than method 1, but nonetheless you'll end up with the same answer. Again, with method 1, I'm just getting common denominators, so here it was 4. Common denominators over here were 24. And down with method 2, your job is to look, in this case, at all 3 denominators and figure out what the least common multiple of all 3 of those denominators would be, and that was 8. So I multiplied every term by 8 and ended up clearing my fractions. Over here, 24 was the common denominator, so I multiplied everything by 24 to get my fractions cleared. And when you see whole numbers, remember, it's really over a denominator of 1. Alright, let's look at another situation that might turn up. And that might be a situation where you have equations that are chock full of decimals. Now, a calculator can handle this no problem, but you may want to just know how to do it for future use in case you can't use a calculator. And so what you do in looking at example A is you're going to decide what power of 10, meaning 10, 100, 1000, etc., what power of 10 do we multiply that would clear all the decimals? And that kind of depends on how many decimal places you have. This number here, 0.5, is 1 decimal place. This one's 2 decimal places, and that one has 2 decimal places. So the power of 10 that will get rid of all the decimals is 100, 2 zeros for those 2 decimal places. So you're really going to multiply both sides by 100. And remember, that just moves your decimals over that many places. So 0.5, you'll move the decimal over 1, 2 places. And you'll end up with, sorry, that's a mess, 50A. Then for the second term, 8.75, again, multiplying by 100 means you're going to move it over 2 decimal places. So that's 875. And over here, you'll have 1,325 after moving it 2 decimal places. So then you can just go ahead and finish solving it. I'm going to go ahead and undo the added subtracted term first. So I'll subtract 875 from both sides. Oops, wrong color. You get 450 over here and 50A over here. Divide both sides by 50 to finish, and then there's the trick of crossing your zeros out, and 45 divided by 5 is 9. So that was a lot easier than having to deal with those decimals. That's an A. Alright, let's look at the second one. I have 2 decimal places in term 1, 1 in term 2, and 2 again in term 3. And so you need to look at the greatest power of 10. That will eliminate all those decimals. And once again, because there are 2 decimal places, you're going to want those 2 zeros to move those decimals over 2 places. This would leave you with 11p plus 150 equals 249. Go ahead and subtract 150 from both sides. So you get 11p equals 99, and then divide by 11, and you end up with p equals 9 in this case. Alright, you try the last 2 guided problems. The least you should do is figure out which multiple of 10 would work to clear those decimals. Pause the video now. And here are those final results. The important thing is for number 1 that you knew to multiply by 1,000 to move your decimals, and number 2 only required you to multiply by 10. You end up with big numbers, but it's nothing that doesn't end up, doable. Alright, thanks for watching.